Differentials are a straightforward concept in calculus. Suppose I have a function f, and I know f as c, f evaluated at some point c, so I know that point. And suppose I move over some delta x, and I evaluate the function at c plus delta x, and f of c plus delta x. This is actually along the curve. Now sometimes this is too hard to do, or it's just a pain. So sometimes we want to approximate it with a tangent line. Now you remember the tangent line at cf of c is y is fc plus f prime of c times x minus c. This is the tangent line approximation. Now the first thing I want to do, let's go back and let's look at what delta y really is. What is delta y? It's the y value from f of c and f of c plus delta x. So that the actual delta y here is f evaluated at c plus delta x minus f of c. This is the real value. But what if I wanted to approximate that with my line? Let me go back to blue. That's this right here. That approximated delta y is the slope times delta x. So this is the approximated value. Now I don't want to write this approximated sign, so I'm just going to call it the differential of y is equal to f prime at x dx, and this is true at any point. Now the definition of a differential is we're going to define the differential to be dy is f prime dx. And we're going to use the approximation that delta y is approximately dy, and delta y is approximately the slope times dx, or f prime times dx. Let's do a comparison of delta y and dy. Let y equal x squared. Suppose I want to find dy when x is 1 and dx is 0.01. Well, let me let y equal f equal x squared. Then f prime of x is 2x. Now I'm going to come over here. F of 1 is equal to 1 squared, which is, carried away there, 1. F prime of 1 is 2 times 1, or 2. So I'm looking for dy. dy is f prime of x dx. So I'm really looking for f prime of 1 times dx. In this case, dx is 0.01. F prime of 1 is 2. dx is 0.01. So my differential of y is 0.02. Now let's compare that for delta y when x is 1 and delta x is 0.01. Now delta y is f of x plus delta x minus f of x. All right, so I'm just going to plug this in. F of x plus delta x. Well, x plus delta x is 1.01. All right, so this is 1.01 squared minus f of x. So this is 1 squared. When I do this, I get 0.0201. So my actual value is 0.0201, while my approximated value is 0.02. And for many applications, this is often close enough. And so you can see why using the differential in some ways is often much easier than finding the actual value.